So in this video, we're going to be working with perimeters and areas of similar polygons, right? Theorem type 7 says that if the scale factor of two similar figures is a over b, then the ratio of the perimeters is a over b, and the ratio of the area is a squared over b squared. So the perimeter is the same scale factor, and the ratios of the area is square the scale factor. Right? So let's see. Some instances of the figure in each pair are similar. Compare the first figure to the second. Give the ratio of the perimeters and area. So the ratio of the perimeter again is the same as the scale factor. So in this case it's 6 over 8. So we can simplify this to 3/4. Right? So the perimeter, this is the ratio of the area of the perimeter, and the ratio of the areas is square that scale factor, so it's 9 over 16, and that's it. Second one, I have my scale factor is 10 over 15, so that is 2 over 3, right? So the ratio of perimeter is the same as the scale factor, so 2 over 3. Right? And the scale factor of the area is square the scale factor, so it's 4 over 9. So the figures each pair are similar. The area of one figure is given. Find the area of the other to the nearest whole number. Right, so I have the area of my triangle, my smaller triangle, so that one is 12. So I have 4 over 8 is my scale factor. So my scale factor, this one is 1/2. Right, so I have that 1/2 square equals the smaller area, 12 over b. So this is the same as 1 over 4 equals 12 over b. Now I'm just cross multiplying, so b equals 48 inches square. So now it says that the pentagon, the largest pentagon, has an area of 135 centimeters square. So again, I have my scale factor. Let's start with the scale factor is 8 over 24. So this is the same as 1 over 3. So 1/3 square equals the area of the smaller one, so a over 135. Right, so 1/9 equal a over 135. Rewrite that a. And now I'm going to cross multiply, so 135 equals 9a. Divide by 9a, so a equals 15. So the area of my smaller pentagon is 15 centimeters square. You find the scale factor and the ratio of the perimeter for each pair of similar figures. So I have two regular pentagons with area of 144 over 36. Let's start with the smaller over the largest. Right, that's the ratio of the areas. Right? But as you know, the ratio of the area is a square over b squared. Right? So if I just take the square root on both sides, I have that this is 6 over 12 equals a over b. That's my scale factor, so I can simplify that to 1/2 a over b. And that's the same as the ratio of the perimeters. So it's also 1/2. Two rectangles with area of 72 over 50. So let's start. Right? So I can simplify that by 2. So this is 25 over 36, right? So my scale factor is the square root of 25 over 36. So it's 5 over 6. And that's also the ratio of the perimeter. It's also 5 over 6. So the circle's width area is 12 pi inches square and 27 inches square. So again, 12 pi over 27 pi. I'm going to start by simplifying so I can cancel out the pi. And by 3, so I have 4 over 9. So my scale factor is the square root of 4 over 9. So 2/3. And my ratio of the perimeters is also 2/3. The area of a regular octagon is 45 feet square. What is the area of a regular octagon? Regular octagon with size 1/3. So this is my scale factor. So the scale factor is 1 over 3, right? So I have that. Let's call area of the regular pentagon. Let's call it A. We know that this one is the smaller one, so I have 1/3 square equals A over 45. Right? So I have 1/9 equals A over 45. I'm going to cross multiply, so 45 equals 9A. And now I'm just going to divide by 9. So A equals 5 feet square. The longer base of a right trapezoid is 12 feet. The longer base of a similar right trapezoid is 30 feet. The area of the smaller right trapezoid is 20. So again, my scale factor here is 12 over 30. So this is 4 over, is actually, instead of 4, is 2 over 5. So that's my scale factor. So the scale factor is 2 over 5 square equals the area small is 20 over the area of the big one. This is 4 over 25 equals 20 over b. So 4b equals 500. And now I'm just going to divide by 4. So b equals 125 feet square. The next one says two similar parallelograms have area of 125 and 80. The height of the largest parallelogram is 10 meters. What are the lengths of the bases? So the base of the larger parallelogram is just 125 over 10. So it's actually 12.5 meters. Right? Remember that the area of a parallelogram is base times height. So if I know the height, I just divide the area by 10 and I get 12.5. That's the base. Now to find the base of the smaller parallelogram, I have now that I have 80 over 125 equals that base. Let's name it B. So B over 12.5 square. Alright. So I'm going to start by simplifying this factor. So by 5, 16 over 25 equals B with 12.5 square. Alright. I can take the square root on both sides. So I have 4 over 5 equals B over 12.5. And I'm just going to cross multiply. So 50 equals 5B. And I'm just going to divide by 5. So that means that B equals 10 meters. So the base of the smaller parallelogram is B is 10 meters. And that's it for this lesson. May the, may the force be with you.